In this practice, show that the following equations. First one is the integrals. Lower limit is minus p to the upper limit is p. Cosine I pi over px times cosine j pi over px dx becomes, when the I is not equal to the j, it becomes 0. When the I equals j, it becomes p. And in the second case is a product of the sine functions. So to prove that these functions, we use the addition formulas. So addition formula for the cosine alpha plus beta is equal to the cosine alpha cosine beta minus sine alpha sine betas, and the cosine alpha minus beta equal cosine alpha cosine beta plus sine alpha sine betas. We use these two equations to find that cosine alpha cosine beta is expressed 1 over 2 cosine alpha plus beta plus cosine alpha minus betas. So if you sum up these two equations, you will get the cosine alpha cosine betas. And also you could find that the sine alpha sine beta is equal to the 1 over 2 times cosine alpha minus betas minus cosine alpha plus betas. So we discovered these two equations. So when the I is not equal to the j, we'd like to prove minus p to the p cosine I pi over px cosine j pi over px dx is expressed 1 over 2 integrals minus p cosine I plus j pi over px plus cosine I minus j pi over px and the dx. So we use the first equation to change the cosine I pi over px cosine j pi over px into the two terms. Then we could perform these integrals. It becomes 1 over 2 I plus j pi p sine I plus j pi over px plus p over I minus j pi sine I minus j pi over px. And the lower limit is minus p, upper limit is p. So if you substitute px equal p sine integer multiple of the pi, it becomes 0. Also if you substitute x equal minus p, also it becomes an integer multiple of pi, it becomes 0. So you can easily find this becomes 0. When the I is equal to the j, so it becomes minus p to the p cosine squares I pi over px dx. So it becomes 1 over 2 cosine 2I pi over px. So you could consider this part, it becomes I equals j, it becomes 2I. So 2I pi x. So this becomes 0. Cosine 0 is a 1. So plus 1 dx minus p to the p. Integral of the cosine function in this case becomes 0. But the integral of the 1 it becomes p. So I prove first equation. When the I is not equal to the j, product of the cosine functions becomes 0. When the I is equal to the j, it becomes a p. Also, I'd like to prove the second formulas using this formula for the sine. When the I is not equal to the j, minus p to the p sine I pi over px sine j pi over px dx is expressed 1 over 2 minus p to the p cosine I minus j pi over px minus cosine I plus j pi over px dx. Then you could perform these integrals. P over I minus j pi sine I minus j pi over px minus p over I plus j pi sine I plus j pi over px minus p to the p. So if you substitute x equal p, so it becomes 0. And also if you substitute x equal minus p, so it becomes 0. When the I is equal to the j, integral is minus p to the p sine squares I pi over px dx. So it becomes 1 over 2 minus p to the p. 1 minus cosine 2I pi over px dx. So integrals of the cosine function, it becomes 0. So integrals of the 1, it becomes p. So I proved second equations. Okay, this is the answer to this practice.